move on forward, and we have an empty table of users. Our next step is going to be actually loading that table with actual users.
Okay, sorry, I didn't.
Yep, just to go back to here, we're setting up the view structure like this. So tab bar is our root. We're going to have 2 or 3 tabs. Each tab will contain a navigation controller, and then each navigation controller will contain a table view controller. In this case, we just have one because we're just showing users. So that's why here, if we look at our code, so we create the table view controller, we put that inside a navigation controller. We take that and we put that inside the tab bar controller right here. And then the tab bar controller is our main view that will show in the window. Does that make sense?
Yes, I follow. Thanks.
Okay, cool. It is a little bit like a Russian doll, but it does allow us to have some easy, fluid navigation and user interfaces here. There are better ways to do this. For the sake of this workshop, I'm trying to keep it simple. So I would highly recommend, if you want to save what you have, you can feel free to do that. However, I think just to move along smoother, I would recommend going to the next step. So if you do have whatever Git client you want to use, you can go ahead and skip ahead to step 1. So as you can see, we simplified the code quite a bit. The reason being that none of these like this constructor here doesn't exist, and this function doesn't exist. So I went ahead and created it. The way I did that is by using what's called an extension. So we have 3 extensions here. You probably can't even see them because they're super tiny. But let's take a look. For instance, UI tab bar controller. I created a convenience constructor here. And what that does is it's a way to create a convenience constructor that kind of does some of the steps that we had done, but kind of encapsulating it in a single method. So as you can see here, we went ahead and we created we took this parameter here. So these are the actual parameter names of what's passed into the method. How many of you are familiar with what a map function does? Okay, so we have a map which takes in a closure or function essentially, and it takes in each item in that array. As you can see, this has square brackets around it which signify that it's an array or list of items. So for each one of these items within this array here, we are going to encapsulate it within a navigation controller. And I'll explain this part in a little bit. And then we basically are taking, what we had done before was we took the table view controller, we put it inside a navigation controller. Well, that was a lot of manual work. So rather than having to do that for 3 different tabs that are all basically the same thing, let's just automatically take a bunch of view controllers, put them in navigation controllers, and then put them in a tab bar controller. So that's what we did here. So this map will then return a navigation controller that's then used for our view controller. Let me explain this part then. We have a protocol called tab itemable. How many of you know what a protocol is? What's another word for a protocol?
Interface.
Yeah, exactly. So we have an interface here essentially, which is asking for the implementation of a function called configure tab item. This is something that I created. The reason being is to put the functionality of that customization of the tab item that we had done in the app delegate and move that into the view controller. So for instance, our users table view controller, we have an extension on that as well, which implements configure tab item. So if you remember, we had this functionality in app delegate. We actually went ahead and moved it into the view controller by using the tab itemable protocol. I'm going to go back to tab bar item. So what we do here is we try to cast it, our view controller. That's what this as question mark means. It is a way of casting it. If it is not cast, we will get a nil or null, depending on what language you're using. If it is successful, this will pass through this if statement, and then we'll run configure tab item on that object. That's a lot of stuff to go through, so it would be helpful to me. What questions do you have? Where should we start?
It's a good question.
Yeah. So let's break this down. We are taking each view controller and converting it with the map to a navigation controller, which contains that object. We're saying if it has the functionality to set up the tab item. So that's what this as thing does. If it does, then it'll go ahead and configure the tab item, or call configure tab item on that view controller. And then here's where we just went ahead and set the view controllers. Does that make sense?
Mostly.
Okay. We're going to go over this again. So I just wanted to show some ways that extensions are used and a convenient way of kind of refactoring some of your code to make it easier to understand. UI window, this is probably a lot simpler. So if you recall, we had these 3 steps in our app delegate. I basically created an extension that kind of does that in one step in the app delegate. So in app delegate, we call make window key and visible with view controller tab bar controller. So I just basically took that and put that into a separate method onto itself. One thing I want to point out, and this is something a lot of people aren't familiar with, is the idea of this here where we have 2 words. This is like what's called kind of a parameter prefix typically, and it's a way to give your functions more of a easier to read feel. The actual parameter name is going to be this part here, but in a lot of cases you'll want to add a prefix. A lot of people don't like them because they're not used to them in a lot of other languages. I think if you use them well, they can really bring a lot of your code, make it more readable, essentially.
So I'm sorry, explain to me one more time prefixes then.
Yeah, so if you look here at the app delegate, you see how I call it? I say UI window, make window, key and visible with view controller.
Yes. So that's just the prefix.
That's the prefix, yeah.
But here.
And then this is the variable name, and this is the prefix, or parameter name. So then when I use this actual view controller here, I use it like that.
I think I understand.
So if I
So,
change,
okay, sorry.
It's almost like making documentation part of your code.
Yeah, because I mean, I would expect like key invisible with the view controller colon.
consider this,
Right,
consider it
prefix,
part of the
prefix.
function name more than it is part of the parameter.
Got it.
Is it like a type kind of thing? Or
Nope, the type is here defined after the colon. Thank you for asking that. So that's this part here. And I'll explain the question mark in a little bit as we move along.
So what is the use of that prefix?
To make your code more readable.
Okay.
But it's not optional.
I could do this if I wanted to. Like that. Let's see. I think that we'll go. It's going to throw an error. And I think it's because it's the first parameter. It'll just use whatever that is.
Mm-hmm.
Let's say we wanted to get rid of that, though. We can go in here and put an underscore. And then this will just take it as is. Like that.
Okay. Yeah, that might take a second for me to wrap my head around.
Yeah, prefixes are a little bit weird for people who aren't used to that. Okay. So let's go ahead and we're going to actually make our user table view controller load data. This is going to be the hard part. Yeah, I know. Probably like this is already pretty difficult. Sorry. It's a lot to get through. So we're going to go and we are going to first create what's called a table cell. So you should have under views a zib called users table view cell. So users table view cell, we're creating that. That is just going to be a code file, which will connect this .zip file that you see here over to the to actual code. So we're going to hit this little Venn diagram thing. And we're going to select manual. There we go. That. So what I want is on the left side the code and on the right side the zip. If you need help with that, please let me know how to do that because it can be a bit tricky. So select the Venn diagram so we have an assistant editor, and then on the left will be the code and on the right will be the zip, which is this view here. Anybody needs help with that? So over here, we're going to connect each one of these views. And the way to do it is use the control button on your keyboard and drag it to your code like that. Oh, excuse me. You know what? You need to first select the view and then set the custom class to our users table view class. Carly can barely see that there. So select the top view here and then set the class to users table view. So and then you should be able to drag this over and create an outlet. Well, we can call it avatar image view. And what that does is it connects the user interface to the class. So that way, when we change this property on the code, in code, it'll actually change what we see here on the iPhone. So I'm going to drag each one of these over. So, yay, my favorite thing. Okay, we'll drag the username over. So I'm going to call it username label. We're going to drag this badge over. It's a label, so we'll call it badge label. And then we're going to drag the summary over. Summary label. And now we can manipulate that stuff in actual code. Now we need to actually create these cells in our table view. So go to our users table view controller. We're going to go at the very top at the entry point of where the view controller is actually loaded. And you'll see a method called Viewdidload. And this is here where we kind of start, get the table set up so that we can start loading it with actual cells. So the first thing we're going to need to do is we're going to register our nib file that we have here, this file, so that it knows what we'll be using for our table view cells. Table view controller tries really hard to not overdo too much memory, so it actually reuses table view cells. And that's kind of what you're doing, is you're kind of telling it, this is the template we're going to be using, which you can keep using over and over again, so that way we don't overuse memory on the iPhone. So on the table view, you're going to see a property called table view, which is the actual view. We're going to register a nib. We're going to say UI nib. And with a nib name, the nib name, we can name it anything we want. Or no, this we can't name it anything we want, excuse me. Is the name of the file. So users table view cell. We don't need a bundle. But we do need to give the reuse identifier something. What name do you want me to give it? Pick one. Come on, just say something.
Conf.
Fred.
Confred, good. All right, so we have a reuse identifier. And then we are going to need to get, here we're going to need to add the code for loading the data from our quote-unquote database. So let's take a look at this JSON file here, where our data is stored. So you can see we have this massive JSON file that we've loaded from our REST API we're going to actually be using. So what we're going to need to do is take this and you put it into some sort of structure or class. So that way we can take that data and draw it onto our table view cells. So we have a class here called user, and we need to map these properties out to what we see here. So I'm going to just copy this so we can see what we're looking for. So this is our struct. A struct, unlike a class, is just data. It's not a pointer, which is fine because we don't have a lot of information here. I'm just going to paste this in so we can see what we're looking for. So we see here we have our first property here is an ID, and that's a GUID or a UUID, which you probably have seen. So we're going to give it that. We have our name, that's a string. So we say let name, and it's let because we're not going to change it once it's been parsed. And then we have our avatar here, which is the URL. So let me make sure I get that name right. So we're going to say let avatar URL, and then a badge, which is a string. So badge string.
So all these are data types, and the URL is actually a data type.
Yes, URL is a data type, UUID is a data type, string is a data type.
I was just.
Yep, and the colon is the way to differentiate the name of the property from the name of the type. Thank you, good question. We're going to actually copy these over, and we're going to be making a protocol for our users, so that way for later unit testing or whatever other purposes. So we're going to define a user protocol, and with user protocols, they're all going to be vars, and they're going to be read-only, and the way you define it as read-only is by using the get, because it is only a get property, and it's not settable. Any questions?
Sorry, I had lets in there.
So you can't have a let. You cannot have a let in a protocol. It will not let you do that. So let's go back to user structure. We'll define two. It's going to implement two protocols. In this case, we have our user protocol that we have, and we're also going to say that it implements another protocol built into Swift called Codable. And what Codable does is it will allow you to automatically take that JSON and turn it into a structure, which is pretty nice.
So it only works for JSON?
JSON,
XML?
I don't think XML is built in. JSON's by far the most popular. Probably like a plist, which is like a proprietary Apple.
Key value pair.
Yeah, something like that. Yeah. But mostly it's used for JSON. So as you can see with our, Dave, are you ready? Do you need to still look at this?
I'm sorry, what happened to our gets?
Yep.
Or you just made that codable and that
The protocol
we didn't
has the
need the gets
gets.
anymore?
The protocol has the gets, and then the user is just a bunch of properties.
Got it.
The lets will automatically implement what's in that protocol.
Got it.
since they're
That was
read-only.
just on the wrong spot. Got it.
So this is what the structure is lets, and the protocol is vars and gets, because it's a protocol. You're just implementing functionality. Let's look at the JSON file again. So as you can see with the JSON file, what it is it has three properties on it. It has a users property, which is then the list of users. And then, where are we? Up, and post property. And then near the bottom is going to be comments property. We're not going to do posts and comments yet, if we have time, but we need to have our structure map exactly to how this file is mapped. So we're going to have to create another struct here. So go ahead and create another Swift file. All it needs to be is a Swift file. And then we're going to save it as a data set, or you can call it whatever you like. It doesn't really matter. And you should have pretty much an empty file like this.
Yeah.
Okay, so we're going to create a struct called dataset. And what's nice about Codable and the way that works is you don't need to define every property within your JSON. It'll actually exclude the parts that you don't implement within your struct. So we just want the users, so all we have to do is define that user's property. Now, if you go back to the JSON, go to the top, property is called users, so all we have to do is define users. And then it is an array, right? So to define an array, we put it within square brackets, and we know it is an array of user. Does that part make sense? Okay. So the next thing we're going to need to do is implement some sort of functionality like what this does. So as you can see here, we have a method called users, which returns, which takes in an actual function and spits out the users. So this is what we're going to call in our table to get the users back. The reason I made it asynchronous is to kind of mimic the way a typical network call would be done, right? So let's actually implement this database protocol as an actual database. I use that term very loosely here because all it is tying to that JSON file. So define another empty Swift file. We'll call that database. And we're going to define a object or a struct called database. Let me know when you've gotten this far. And then we are going to say database protocol. And it should give us a warning. That warning says that the type database does not conform to the protocol, database protocol. Red dot. And it'll say, do you want to add those protocol stubs? And yeah, let's do that. And now we have what we need to implement to define that. So what I'm going to do here is we're just going to make the shared one a database like that. So now we have a static or shared variable, like basically a static variable for that class. But we need to actually read in that JSON file, right? So this is the fun part. So go ahead and we're going to create an empty constructor. And our JSON file, if you look at it, is contained both in our app and our watch app. So we need to get the URL. First, we need to get the URL to that actual file. So going back here, let's get the URL to the actual file that's contained within what's called a bundle. So we grab the bundle, the main bundle, and we say we want the URL for the resource with extension. Our resource name is DB, and the extension is, yes. So that gives us a URL, and then we're going to take that URL, we're going to get the data from it. We can do that by calling data, which is essentially an encapsulation of binary data. We want contents of URL, throw in the URL, and then we need the decoder for our JSON, so we create a JSON decoder. And then we will then get our data set. You're going to want to go up here and have a variable for the data set, of course. So remember, we created that data set, which is basically the abstract representation of the JSON file. So then we can go here and we can do self.dataset JSON decoder. Oops, JSON decoder. Decode. What's our type? We're decoding that JSON file to.
Data set.
Yep. And then we want self because we want to actually, it needs the actual type, not just the class. And then we give it our data. And we're going to make it not work. Let me know when you've gotten to this point. So what is the error that we're getting?
Value of
What's-
optional type. URL question must be unwrapped to value type URL.
What do you think that means?
It means I self-type something.
No, you did it right. You
Uh-huh.
typed it right. But what are we not considering here? Yeah. So this method here, bundle main URL, might return a URL. Because what if I go in here and I type, what was it? Was it called confred? Yeah. What if I did that? What's it going to give me for a URL? We don't have that in our bundle, right? So it gives you nil because there is no such file. The way Swift defines something that could possibly be nil is using what's called an optional. So you've seen these throughout, kind of like these question mark types. So you'll have like don't copy this code. Let something equal. We know all the time that something is going to be an actual string. You can see that right there. However, I could also do this. Now, this is a way to explicitly set the type. Now, we don't know if something actually has data in it or it doesn't. So there's a few ways to test this out. One way to do it is you can do like an if-let statement and say that. So in other words, I am saying if something is an actual thing now is not optional, it's an actual hard-coded thing. Do whatever you want. The other way that's commonly done, especially when being nil is an error state, you might want to do something like guard let. Excuse me. So you'll see this a lot lately. And then you could throw an error. We'll get into that in just a little bit. Or, crash the whole darn app if we want to. Whatever you want to do. It's a way to handle optional types.
Can I set a default thing in that?
You mean like a collate type thing?
Or hard code it?
Oh, so yeah, you could do that. You could do this. Actual thing equals something. Question. Confred. It's like that.
Yeah.
Does that make sense? Do you know?
Yeah.
What does this mean? Just so we're on the same page.
I mean, if something is actually not, if it is null, then we use confred.
Yeah. Okay. Cool. So yeah, that's exactly what that's for.
I have a question.
Yeah.
Can you change the letter something is not changeable, then that not changeable is assigned to actual thing. Actual thing.
So I cannot change something, but I can create a new variable that contains the value that something had.
Okay.
Is that answering your question? Yep. That's why I have to create it. That's why I have to create an actual thing. Like I can't change something to something else. Sorry.
Optional
It's getting a little Abbott Costello here.
So optionals take care of cases where you're expecting a data type and it returns a different data type. Is that fair?
Optional is a way to take care of cases where you may not have data available to you.
I see. So it only resolves itself under nil conditions.
Well, you need to define, like the thing about Swift is it's a very strong type language. You need to define throughout the whole entire thread of those function calls that something is optional or not optional. So if you look, I'm taking a risk here doing this, jump to definition here. You can see here's the function. It returns an optional URL. If it didn't, if it was always going to return a URL, you would not have the question mark here.
There it is. Thank you. That's very helpful.
Okay, so now, what do you want to do if we can't find the file? Crash the app, throw an error. What do you want to do?
Send
Choose
off
your own
social security
adventure.
Numbers.
What?
Nothing.
What'd you say?
Send off social security numbers somewhere.
And
So, yeah, we could do this. So guard let. Guard was introduced fairly recently, and it's a great way to like encapsulate error states. So the way it'll work is this part of the code here. It either needs to throw, or it'll throw or return. So,
Well, a guard shouldn't let it execute at all, right? If it doesn't reach the condition.
And then everything after the guard statement, URL will not be optional because that guard statement should take care of it. So if you look at URL, you can see URL is not optional. So that's kind of the idea of guardlets, is to kind of like encapsulate error states where optional occurs. I'm going to be lazy, and because we don't have a lot of time, and just do this and make the app crash, and then I'm going to pretend like I know somebody's social security number. So now URL is taken care of. Great. Now we can run this app. No, we can't. What does it say? It says call can throw, but it is not marked with a try. So let's take a look at this data constructor here and see why we're getting that. Let's go to, no, I'm not going to do that. We'll just do contents of, there we go. Here is the constructor for data. Ignore a lot of mumbo jumbo here. Point being, you'll notice at the end we have a throws. Just like optionals need to be defined throughout the function call stack.
Mhm.
If a function throws an error, it needs to be defined throughout that call stack as well. So we have a function that can possibly throw an error. It makes sense. You put it in a random URL. It could be garbage. It can't pull the data. It needs to throw an error. You might want to ask, when should you throw an error and when should you return optional? You can have hours of discussion on that. I don't want to get into it because there is a possibility of just not giving any data but not throwing an error. So in any case, we need to take care of this.
Quick question.
Yep.
So that throws, just adding that to the end indicates that it could throw an error?
Exactly.
Okay.
Yep. Errors are really easy to make if you ever want to make one. All it has to do, you just need flour, water. No, you need, you just say like, I'm going to go with this throughout the whole workshop. Just implement error. That's it. And then now you have a custom error with any metadata you want to throw to it. Not throw to it, but put it in. So we need try. There's a...
Sorry.
Yeah, no problem. There's a few ways of handling this. We could do the I want it to crash way, which means this. Exclamation mark is used throughout to force something to happen. So I want to talk about that really quickly, but like if we wanted to, if we really wanted to be lazy with this one, we could have done this and then did this. And if URL, basically what it ends up doing is it treats URL like it isn't null, even though it's quite possibly null. You'll see this a lot because of a lot of older code, Objective-C code, that doesn't really care either way. So we could just force it, which is essentially what we're doing here with this try, and say, just do it. And if we get an error, who cares? Crash the app. The other way, and like a nicer way, but not perfect way, is doing try question mark. So try question mark means that instead of doing anything with the error, take that error and turn it into a nil result. So if you look here, data is now going to be optional. The elegant way, so there's a couple of elegant ways of doing it. One way is we can do the try here, but now we have to carry that throw over. So up here in our constructor, we can then do this. But that, of course, means that this is going to complain because we need to do a try there. I'll just do this, and I want it to crash there. So if you don't want to do that, if you don't want to carry your exception over, your error over, you can do a do, and then you could do a let catch error. And now we have our error here, which we can do whatever we want with it. Display it to the user, throw it to Crashlytics.
Yeah, either crash the app or let the caller know that this throws an exception.
Or we ignore it and make it optional.
Make it optional.
Yep. So I'm going to go with the one where we carry it through and then we let it crash, just for the sake of simplicity. This should work. Let's see. Okay. Does anybody know what I'm missing here? What does it say? It says dataset needs to conform to decodable, which is one of the things that Codable implements. So we just need to go back to our dataset and just make it implement Codable. That's it. Now that should work. Let's try to compile. What's it complain about now? Oh, so again, another method that could throw a function or throw an error. Great. So now we have a compiling app. Let's go ahead and implement this users call here really quick. That's fairly simple. So completion. So completion is a method. So you would actually give a method as a parameter in this function. So completion, as you can see here, here we go. It's an actual method. It takes in a result that could either be an error or a array of user protocol. So if you look at result, excuse me, you'll see it is an enumeration. This is a great opportunity to talk about Swift enumerations. They are weird because we all know enumerations, they're simple. It's just case, case prop value, case value, like really simple stuff. You have what's called associated enumerations in Swift, where you can actually have properties on enumerations. We also have here a generic. How many of you are familiar with generics or template classes? Okay, so a result is actually a generic class. You define a success type and a failure type. In this case, we define our success type as the list of users and our failure as an error. So the success case actually takes in whatever that success value is, and the failure case actually takes in the error that it is throwing. I tossed a lot there because it's generics and enumerations, and it's not something you're probably familiar with. Any questions about that you want to ask me? Throw the hard stuff at me.
My takeaway right now is really, really hard to get even a simple app going with iOS. Is that
yeah.
Okay, I'm good with that.
I think, yeah, well, you could do stuff with storyboards, but I think I'm more interested here in having you understand Swift than it is so much understanding how to build a simple iOS app. And this is just a way to kind of show how some of the complexities of Swift, because you probably could get an app going in 5 minutes,
Sure.
but it will be useless.
My takeaway, so what I remember from Swift when it was first released, that it looked very Python-y like.
Interesting.
What I'm seeing now is it's like I see parts of Haskell, I see parts of C++ templates. It's such a bizarre language. Like, I am curious with it now.
So here we have our generic enumeration, which has two cases, success and failure, which both have the value of failure and the value, whatever success value and whatever failure value. So we're going to go over here and we're going to call completion, which is our method. And we're going to tell it that we have a success. And then we just need to grab the list of users in our data set. And so we're calling a method. So the variable is a method. And then we're telling it we have a success, and then we're telling what the success actually is, which is that list of users. So let's go ahead and we should be able to compile this. And then we're going to go into our table view controller. And we're going to grab that list of users. So we have Viewdidload here. We registered our cell. Now we're going to get the list of users. So let's go to our database. We're going to grab our shared database that we've already created. We're going to call the method users. So remember we had completion. So this is our completion method that we're giving it. This is, if we wanted to, we could just so that it's a little bit more readable for you. Keeps doing that. But we could put the method as completion, like in the parentheses. It's a shortcut that it automatically does for us. But in any case, so we have our result, and then we need to grab, we'll do like a switch case statement, right? You're familiar with that. So we only want the success, and we want the users. And then we need to store the users somewhere. So I'm going to just do users, user protocol. It's optional because we're not going to have anything when we first start the app. And then we're just going to assign users to users. So you're familiar with switch case statements. So there we go. So this is our case we're going to take. We're going to take care of the success case. And then we have our users, which we get back from the success case. We're going to set that to our variable within our view controller. Any questions? So after that is done, we need to reload the table. And we do that by grabbing the table view property and doing reload data. Now we need to actually draw the cells. And there's a couple of methods to implement when you do this. First is the number of sections. We actually don't need that because we only have one. We're going to remove that. But then here at the number of rows, we need to grab the number of users. So here we can do self.users.count. Again, users is optional, right? So if what's called optional chaining, if you grab an optional variable and try to call a property on it, you can still get nil in that property. It doesn't crash, it just returns nil. And it'll carry that on to each child property. So we're going to do what we had talked about earlier and do a double question mark 0, because obviously if users is nil, we want it to be act as if there are no users. And now comes the part where we actually draw the cells. We're going to use our reuse identifier to grab our cell called confred, the wonderful name. And we are going to do that. We have a cell, but you'll notice our cell does not have any of the properties that we had set up. Let's go back here. Here's our properties that we had set up that connected to our interface. The reason being is that cell is just a UI table view cell. We need to cast it. So we're going to go ahead and do a guard statement and try to cast it. Call it user cell. We're going to try casting their cell as that proper type, which we had created. And then we're going to we'll just return the generic cell rather than trying to throw an error or anything like that. And now we should have users cell, and we should have things like our name label. Fantastic. We also need to grab that user. So we have here an index path, which tells us the section and row of the cell. So we can go right here, and we're going to grab the user by doing users. Again, it's optional. I don't want it to crash, so I'm going to do guard let. And then I'm going to grab the row. So index path has both a section and a row because there are tables, and you probably have seen this in apps where they divide the table view into separate sections. So we just want the row because we don't actually use the section. And we're going to do else, and we're just going to return an empty cell if we don't get an actual user back. Now back here, let's set the name, text, and that's the user name. Yep. Users cell dot, what else was there? Badge, right? User dot badge, users cell dot our avatar image. I think this we're going to need. So we need to get the data first. So contents of URL, user.avatar. I think that's it. And then we have the summary data, which we're not going to be able to get to today, but that, let's try that out. We want to do that. We should have one error remaining. There we go. So, surprised that actually worked. One thing I was going to mention that I thought was going to error out was it's always best to do any UI updates on the main thread. This will be the last thing we'll do before we close out. So this is a way to grab the main thread, and then we're just going to do an asynchronous call to reload the table. You'll notice at times you're going to update the UI, and nothing will happen. It's because you probably didn't do it on the main thread. So you were asking earlier, it seems like it's not very simple to create an iPhone app, correct?
Well, I mean, there's a lot that goes into it as you're writing out Swift, right? And that was surprising to me.
Okay.
Yeah.
Watch is worse. I'm just going to tell you that. So,
All
well, the watch.
And I think you can actually build a fairly useful app with storyboards only.
Yeah.
Mm-hmm.
So, I mean, we're going down the Swift path, not the iOS path.
Right.
Sure.
So,
Which is interesting to me. Yeah, it's not about, understood things.
Yeah, that's one of the things I wanted to emphasize. Like, this is more about teaching how the ins and outs of Swift than it is about storyboards, which are pretty much going the way of the dodo anyways.